There we go. Hi, everyone, and welcome. My name's Chris Little, and this is the latest in our ongoing series of connectivity webinars for various drivers and communication methods within VTScada. The last few have been focusing on new drivers available soon in VTScada version 12. Thanks for tuning in. I'm coming to you live from our Bedford office, our headquarters, where the majority of our development takes place. And joining me today is Graham Bloice, who is one of our developers in the other office that does primary development, and that's Aberdeen, Scotland. Hi, Graham.
Hi, everyone.
Let me put up our slides here. So I've been with the company about 13 years. You may have heard my voice or seen my face in just about every other webinar. And also, if you're one of our customers in Ontario and Quebec, I am the primary VTScada sales contact for that area. And Graham is one of our lead developers. Why don't you tell us a little bit about yourself?
As we can see from the slide there, 21 years with Trihedral now in the R&D department. Primarily concentrating on our engine and drivers, but a few other things as well. Lovely company to work for, great products. And as a little sideline, I'm also a Wireshark core developer. If you've ever done any networking troubleshooting, you've probably come across Wireshark. Fantastic tool, and again, a fantastic team that works with that as well.
That's great. So before we begin, for those of you who have tuned in before, you'll know this song and dance, but a few things to remember. One is that if you have any questions, we're going to try to stick very closely to our 30-minute format. So 30 minutes of content, and then after that, we're going to start answering questions. So at any point during the webinar, if you have a question about what Graham's talking about and describing, there is a little box on your GoToWebinar interface that should be up in the top right corner of your screen where you can enter questions. So at any time during the webinar, please just keep firing those questions into the box and hitting enter, and they will go into a list. And at the 30-minute mark, or roughly thereabouts, I will start to pitch those questions at Graham, and we will go as long as we have questions. So if you need to tune out after 30 minutes, you have to get on with your day. Don't worry, all those questions will get answered, and everyone who has registered, whether you either attended this webinar or had to leave early, everyone will receive automatically an email with a link to the recorded webinar and also to all of the slides. Also, if you're looking for some light reading during the webinar, there's some links in your interface to a couple of documents, such as our driver list for version 12, and also new features coming up in version 12. So feel free to look at those. Those links will be sent on as well. Graham, am I missing anything?
I think we're good.
Okay, great. I am going to transfer control over to you, sir.
And I should be live there now. You can see the same screen there. So that was a little introduction there from Chris. And now we move off into OPC-UA. UA is an abbreviation for Unified Architecture. Originally came out in 2008. From much the same people that have been involved with the original OPC, called OPC Classic nowadays. And it has a wider scope, I think, that they're looking to use it all over the industrial domains, both for HMI and machine-to-machine traffic and IoT as well. And its major difference is it's platform independent. So all different kinds of devices would be able to use OPC-UA. And the other, I think, key factor around OPC-UA in today's environment is that security has been built in to the protocol. It's not an add-on at all. So what is different from OPC-UA and OPC Classic? Well, it still has OPC in the name. Apart from that, pretty much else is quite different. They still have the concept within it of tags and properties of tags, much the same as any other industrial control protocol, but the mechanisms and the way they do that and everything else are all quite different. I think the key factor in that is that there's no use of Microsoft DCOM. That was the networking protocol used in OPC Classic to communicate between different systems, different hosts on the network. And so if you're ever doing OPC Classic between different systems, you were well aware of the difficulties in getting DCOM configured and the security managed correctly. Another nice advantage of it, as it's a specified protocol, somebody at the OPC Foundation produced a Wireshark dissector for it, so that you can look at the traffic with Wireshark and make sense of what's going on, unlike the DCOM Microsoft RPC. And the last bullet point I have there is that, as I mentioned before, security is built into the protocol. You have to actually go to some lengths to defeat it and turn that off, although that is appropriate in a small number of cases. So a little bit of a summary of what we've put in so far in the OPC-UA client driver that appears in VTScada 12. It's only a client driver, so we can retrieve and write data to OPC-UA servers, but we can't act as a UA server ourselves at the moment. UA has a number of ways to transport the data, and we've chosen to use the TCP transport with binary encoding. There are other transports such as HTTP and other encodings such as XML, but they don't seem to be particularly well supported by devices. They're much less efficient than the TCP binary, so that's why we've gone with that transport. Hopefully it'll be well supported with all devices that you wish to use it with. And we've also added support for most of the OPC-UA data types. And on the right-hand pane there, I've listed all the ones that we've supported. And you can see it's a little bit similar to the data types that were used in OPC Classic, the addition of 64-bit integers, and some specific things to do with OPC-UA about how they identify items, GUIDs, node IDs, status codes, and things like that. But the basic ones on the left, I think, are the Boolean down to date time, the type of values that you'll be needing in an HMI, and we cover all those off. So now we'll jump out of OPC-UA directly itself and into a key bit that's used with the security with OPC-UA, and that is X509 certificates. These are the certificates that you use on web browsers and web servers and so on. So it's the same type of certificate, and they're used within OPC-UA primarily for endpoint identity, that both ends have to identify themselves with a certificate, both the client and the server, to ensure that the machines involved in the communication are actually authorized to do so. Within the certificate, we've also got a public key, and associated with the certificate there's a private key, and those are used to encrypt data, and that's the second leg of the security task within OPC-UA, is to run data confidentiality. So that encrypts all the data so that it can't be snooped by anybody else within the communications. And then the last step on that the certificates are used for there is message integrity. Again, using the public-private key, all the messages within OPC-UA can be signed. And this allows the receiving end to ensure that the message hasn't been tampered with in transit. So by using X509 certificates within OPC-UA communications, we cover off those three aspects of security there. And so for use with OPC-UA, you need to obtain a certificate. And there are a number of sources to get a certificate. You can actually go and purchase one from an external certificate authority. Many of them around, all the usual favorites and the hated ones as well. And you could also use a free certificate from Let's Encrypt, say. So those are an external trusted certificate. You may well have in larger companies your own PKI, public key infrastructure, or certificate authority. So for instance, Microsoft have a certificate services feature that can be added to their servers that will be able to generate certificates. And those certificates are generally trusted within the enterprise. And then the last option is a locally generated certificate. And this is known in the certificate world as a self-signed certificate. It's one that's produced on the machine. And that generally is only trusted on that machine. But through the magic of certificate trust and various other aspects that we'll cover off in a few later slides, we can make sure that certificate, again, is trusted at both ends. So that's a brief overview of the X509 certificates that we use in OPC-UA. And as I mentioned, a key aspect of certificate is trust. And so there's two types of trust on an X509 certificate. It can be explicitly trusted because the certificate is signed by an authority that is trusted by software on your machine. And a typical example of this is an external certificate that would be signed by the external certificate authority issuing it, such as DigiCert. And they already have a root certificate on your machine that's updated by Microsoft in the Windows Certificate Store. It's actually in that level on the right-hand pane in the Trusted Root Certification Authorities node. And that root certificate there ensures any certificates issued by that CA, certificate authority, will be trusted implicitly by the system. And if you have an internal CA, such as Microsoft Certificate Services, again, that certificate will be trusted within your enterprise. And then the last option for locally issued certificates is you can do an explicit trust within VTScada. And we will say this is a manual certificate. We don't normally trust this, but we can, by configuration, trust it. And just as a little bit of info, if you were doing these certificates manually on the system, not through VTScada configuration, these are the certificate stores where you would be putting the certificates, the client certificate, and then the server certificates in the trusted and untrusted stores. We'll come over to that in a few more slides when we actually look at configuration of the client driver. So now I've jumped into the first tab, well, sorry, the second tab of the OPC-UA client driver that you will see in VTScada 12. The first tab is the ID tab, common to pretty much all of our tags and drivers within VTScada. That just gives you the name and description of the driver tag. So from the OPC-UA specific point of view, the connection tab is the first most interesting one. And we have a couple of options in here. The first one is, the key one, is the endpoint URL. This is the URL of the server that you're going to connect to. And for, as I mentioned previously, we use the OPC TCP transport. So the URL schema there is opc.tcp at the front of the URL. After that, you'll have the / and then the FQDN, the fully qualified domain name of the server. And that has to be a full name because it has to match what will be in the server certificate. The server certificate identifies that server machine, and the name has to match the name that you put in the URL here. And then you can have an optional port at the end of the URL, the colon, in this case, :49320. The OPC server that I'm testing with runs on that port. There is a standard port for OPC-UA, which for the life of me I can't remember, so you wouldn't need to provide it if it was running on the standard port, but apart from that, you can just explicitly put the port there. The other checkbox there allows unsecured connections, and as I put in the description on the right, it allows you to make a connection without encryption and signing, i.e. you turn off all security if the server supports that mode. And as I've noted there, I've not recommended that for production use. It may be needed in testing or something like that if there's something going wrong. But generally in production use, you want the security on. I kind of view that as a career limiting option, because if you turn off the security and things do go wrong from a security point of view, then the finger will be pointed at you. So the next tab is authentication. So we haven't got on to certificates yet, but still you need to authenticate, or you may need to authenticate to the OPC-UA server as a particular user. The server may have user roles and permissions for a number of users, depending on how complex the server is. So you may need to pass user authentication information to the server. And we have three options here that we list. Anonymous, where you're not actually passing any user information. Username, and which is the one selected here, which then enables the two fields on the right to enter a username and password. The password is stored in an encrypted form within VTScada, so it's secure there. And then the last option is to actually send a certificate as a user. And so if you select that option, then the buttons there below become active. So you can create a new certificate. You can select which one of the list that you're going to use. You can import a new certificate. So if you have a certificate provided by your internal infrastructure, say Microsoft Certificate Services and so on, you can import that certificate, and then you can also remove certificates that are no longer relevant to you. I don't know how often that would be used. It's available in the spec and we've implemented it, but it seems that most servers don't really use that. But the options are there. Generally, I would expect just using the username and password. So now we come on to the first of the certificate tabs. As I mentioned in the discussion about X509 certificates, we have certificates at both ends to identify both the client and the server. So this tab of the config folder is allowing users to set up the client certificate. Now the client certificate is specific to the machine making this connection. So if you have a redundant VTScada system, then you'll have two clients, both potentially making a connection to the server. So you'll have a different certificate on each client, because the client certificate has to have the machine name in. So what we do is we attach a friendly name to that certificate, which you'll see in the left column there, certificate name. And that should be the same on both machines. And that allows you to set the configuration here, which is shared between both machines. And then that means both machines will pick up the appropriate certificate from the friendly name for their particular machine and send that off to the server. We have a number of buttons there, similar to the previous tab, where we can create a new local certificate. We can then select which certificate we're going to use. That's indicated by the asterisk next to the certificate friendly name. We can import a certificate, again as a PFX file. That's the Microsoft usual format for certificates that includes both certificate and the private key. If you obtain a certificate from elsewhere, then usually in the form of a PFX file. You can convert various other formats to a PFX, but that's sort of advanced certificate work. We just handle a PFX file. And then you can also remove old and expired certificates. The certificates have a lifetime, and so at some point you are going to have to generate or import a new one, and the driver will automatically use the newest valid certificate. You can then switch over with the using selected there to make sure you're using that newer valid one and delete the old one, and it will no longer be used. We list some information about the certificate there, the friendly name, and we list the issuer name. Now, for a self-signed certificate, that's going to be the local machine. I've done this on my machine here. So that's my machine name, gmb.trihedral.com. If that's come from somewhere else, then the issuer will be the name of that issuer, such as DigiCert. We have a little column validity, whether we VTScada decides that the certificate is valid, and that's where we've done checks on the start date, the end date, and whether we trust it or not. A local certificate is always trusted. And then after that, we have the thumbprint. Certificates are quite complex and unwieldy items, and so they're better identified by a thumbprint, which is actually a hash of the certificate data. Now, for the client certificate, not particularly relevant, although when you're looking through certificate stores and so on, knowing the thumbprint of particular certificates is useful. So it's a useful bit of information there, but not particularly required for what we need to do on the client certificate tab. So to recap this tab, we use this to set up the certificate that the client, which is VTScada, will send to the server. We can either import the certificate from elsewhere, it could be generated by an external CA, internal CA, or actually come from the OPC-UA server itself. Some of those can generate certificates for their clients, or it can be a locally generated one. And we can also pick which certificate's going to be used.
Just before you carry on there, Graham, I just wanted to jump in. We've had a number of people join us who just joined us, so I just wanted to say to them welcome and invite them also to type any questions that they have into the GoToWebinar interface that they can see on their screen right now. And at the 30-minute mark, we will start answering those questions, and also to let them know that if they are tuning in late, not to worry, we will be sending everyone a link to the recorded webinar so they haven't missed anything. Great.
Thank you, Chris.
Thank you.
And so moving on, we now come to the server certificate tab. Now this is the certificate that the server sends to us. So when you initially create the connection, the two machines, the client and the server, exchange certificates, and they examine these certificates to see if they are valid and trusted. And if they are valid and trusted, then they can use those certificates to set up the secure channel between the two devices. If they are not trusted or not valid, then errors will result and you will be unable to set up a communication channel between the two devices. So we must ensure that the incoming certificate is one that is both valid and trusted. So depending on how the certificates have been added to the OPC-UA server, depends whether they're implicitly trusted or not. If it's a certificate that's been generated, again, by an external CA or by an internal CA, such that there would be an implicit trust on it because your machine trusts that, then it will appear straight away in the trusted certificates. And of course, as long as it's valid as well, the expiry date and so on. If, however, the certificate is a self-signed one on the server or comes from a certificate authority that you don't trust for some reason, that's not implicitly trusted on your machine, then it will appear in the untrusted certificates list. And to enable communications to this OPC-UA server, you must manually trust it. So you would select the certificate in the bottom grid and then use the Add Trust button to move it to the top grid. But what you're doing here is enabling communications to a remote device. So you really want to make sure as far as possible that that really is the device you're expecting. So this is where the certificate thumbprint really comes into play. So we will show the certificate thumbprint there, and then on the on the UI for the server somewhere it should list its certificates. You should be able to see the certificate that it's going to be sending you, and they should display the thumbprint somewhere on that certificate. And that will allow you to verify that the certificate that the server that you hopefully have physical access to or remote access to is sending you the certificate that's appearing in our untrusted certificates list. So once you verify that, then you can move the certificate by clicking the Add Trust button there to move it to the top list. And once it's in the top list, then the VTScada OPC-UA driver will pick it up and will start communicating with the server successfully. If you don't have a valid and trusted certificate, the driver will keep trying, but each time it will get back a certificate, the same certificate that's still not trusted, so it will not be able to proceed in the communications. And the last tab on the config folder is the diagnostics tab. So we've got several panes of panels of data there. The top one, as you can see, is a bit of server information that we retrieve initially from the server, but we can refresh it. May be useful in diagnostics and debugging. If you have an issue with a particular server, our support people would probably like to get that information out of there so we can know what kind of device it is you're communicating with. In the center panel, we list the expiry dates of the certificates that are in use. So we can see the server certificate there, quite a long lifetime going up to 2029, and the client certificate just valid till next year. If you are using a certificate for the user authentication, then that will also appear there. And as you get nearer the expiry dates, we gracefully change the color of that to alert you that things might go wrong in a little while. What happens when a certificate expires is that we can no longer communicate with the device, or if our certificate expires as the client, the server will no longer communicate with us. So it's important that these certificates are renewed before they expire. The last box there, the diagnostics, on the diagnostics tab, the communication status, there is a slight typo on that image there that I have fixed yesterday. From communication to communication, but I didn't update the image. And that tells you information about the actual connection that's live at the moment. And there are two parameters in there. The security profile, that's buried deep within the OPC-UA specifications. There's a whole list of different security profiles with different encryption strengths and so on. And so this one is the 256-bit encryption, quite secure. And then underneath that is the security type that tells us a bit about what we are actually doing with that security, and we're both signing and encrypting here. We have a little last box there, minimum security, which if you check that and then click the Restart Comms button on the right, we will attempt to remake the connection to the server with the minimum security offered by the server. That may be none if it offers that in its profile list. And again, this is purely sort of a debugging type effort. If you need to capture the traffic and look at what's going on, then you can do that minimum security. If you set that on, then you're running, as I say, without security. When you close the dialog box, that will be removed from the driver, and the driver will reconnect back in secure mode again. You can also uncheck the box and click Restart Comms. So within a tag, I've used an analog status tag here. When you come to configure it up to an OPC-UA server, unfortunately OPC-UA addresses are complicated, and we really don't expect people to be typing these in. As you can see there on the right-hand pane, I've listed a relatively simple one there. So we have provided Address Assist for OPC-UA, much like we have for OPC Classic, where you click the button and you can see you can browse the OPC-UA server and pick the tag that you want this particular VTScada tag to get the value of. And whilst we're on this particular config folder, the scan interval there, that sets the maximum update rate of the tag from the OPC-UA server. So it's effectively like a poll rate, but we don't poll as such like in Modbus. We get updated at that rate by the OPC-UA server. So I'm just going to pause the slideshow here and just show on the OPC-UA screen here. It's probably a little small, unfortunately. I'm sorry about that. But if we look at the analog status here and go to the OPC-UA button there, we can see the OPC-UA browser here. And when we drill into this one, this is a Kepware OPC-UA server. We have a lot of branches of things, and I have a simulation set up here, and in the simulation a device, and in the device some analogs and some booleans and things like that. And we can see when we select a tag there, we've got a little icon there showing it's a tag that can be selected. We can see properties of this tag, things like its node ID. That a node ID is a particular identifier within OPC-UA, which makes up part of the tag address that you can see up here. And we have various other attributes, tells us the data type and various things, whether it's an array or not. But the key item is it's got a value. The value property is the one that we read from the device, and so this will be reading a Boolean value that's currently false. So you select one of these tag items, whichever one is appropriate, click OK, and then the value will be read in, set into the address box of your tag.
That's great.
I shall jump back to the slideshow now. So I just ran through that address assist there, just showing you a bit live action of what it does there, how you drill down to get to the tags that you want. We also have, in common with all our other drivers, a show stats button that you can drop on a page, which brings up this little dialog. Has two panes. One is top pane is the driver instance info, which version and things like that. And then the bottom pane is the communication statistics, very similar to all our other drivers, number of successful counts and the timestamps and error counts and error messages and so on. You'll notice in the top pane there's a debug log level. We can, if necessary, run some debug logging on the driver. It's really quite dense and complicated, so that would be only on request from support if we were looking into an issue. Normally that value is left clear. We have a couple of other things involved with the UA driver. Because, as I mentioned, I think quite frequently, the certificates are the key to communication between the client and the server. We have some inbuilt alarms into the UA driver when certificates are about to or have expired. So we'll come up with a warning that will start appearing 30 days before certificate expiry. And there's a separate alarm for each of the user and client and server certificates. If you're using a user certificate, that will appear if it's within 30 days of expiry, and we will continue to warn after expiry, but you will also notice that your communications has probably stopped to the OPC-UA server because we require certificates to communicate. And running towards the end now, slightly overrun, but I think we're okay. And we have some resources. There will be built-in help. Our excellent help system, both built-in and online at the VTScada.com website. Once we publish VTScada 12, that help will have the OPC-UA driver help section in it. Our excellent support folks will also be available for any OPC-UA queries. And as a final reference there, the OPC Foundation, who are in charge of all things OPC, can be found at that web address.
That's great.
That's the end of my part now. Over to Chris.
Well done, Graham. Thanks. And I might point out my intro was 5 minutes long, so you have come in exactly at 30 minutes. And I think you are the first and only one to do that, so well done. Let me also point out, in the way of learning about version 12, this will be the third year of our annual SCADA Users Conference in Orlando, Florida, which we call VTScada Fest. So if you're someone who's considering VTScada for the first time, or you're an experienced user who really wants to deep dive into getting the most out of this unique product, then VTScada Fest is the place to go. And certainly this year, there will be dedicated sessions to new features in version 12, but also all of the sessions, because some of these features in 12, such as the universal I/O tag, really touch upon almost all the other features. So the whole thing will basically be in the key of version 12, if I may mix a metaphor. So there's a link there. There's still early bird pricing in effect. There'll also be training sessions. So if you've not had any training, you can squeeze in a basic and an advanced course in the days leading up to the conference, and then onward into sessions and workshops and networking time. So we hope that you can join us for that. And finally, thank you. We have 2 more webinars as part of this series. The series will continue on every month. We try to get one in, and we've been doing pretty well now. The next ones are DMP3 and Siemens. So we hope you can join us for those. As I mentioned before, if you need to jump off right now, no problem. We will send you the link to the recorded webinar either tomorrow or the next day. Also, if you haven't yet entered in any questions, I invite you to do so now. I didn't point out before, you may have to open up your GoToWebinar interface with a little arrow in order to see the questions screen. So right now we only have 2 questions, so this part could go pretty quickly. So if you've got any other questions, please put them in. And also, once the recorded webinars have been sent to you, they'll also be posted to our website. So right now, if you go to our website to the video tutorials page, where you can, if you've never used VTScada before, you can take tutorials from our actual training team and go from 0 to 60 very quickly. And those include a whole section on connectivity and various different kinds of drivers. So all these webinars get posted there, where they've been doing quite well in the way of views. So right now we have 2 questions, and one of them is not a question. It is someone saying, I used Wireshark this morning to fix a COM issue. Thank you for a great tool. So thanks, Graham.
You're welcome.
And the last question is perhaps the one I was waiting for, which is, when will version 12 be released? And the question is, or the answer is, soon. And I would love to give you a better answer than that, but you know, we always try to control expectations. We are hard at work. Things are going really well, but we have an extensive testing period that we go through, because you know, the stakes are high and we want to make sure we get it right. So my final answer is soon. Any other questions? Here we go. What is a good OPC-UA server to use for testing? If you covered this, I'm sorry, I was a late joiner. I don't think we did cover this.
No, we didn't. I've used a couple there. Kepware, which I showed in the demonstration there. Kepware have a pretty good server that's both OPC-UA, OPC Classic, and it can connect to a multitude of different devices as well. All that's built in. I think if you just take the free one, then it will only run for 1 hour against the device, and then not return any more data from the device until you restart it. So Kepware is a pretty good and full-featured one. Matricon probably do produce one. They do everything else OPC-wise, but I haven't actually used their UA server. I may not be free. And the other one that we've used extensively in testing and development was the OPC Foundation's reference server. But that is really not written for, I would say, general use. It's written as I said, the canonical reference server that all certification tests and so on are run against. And so we've been using that when developing the driver. So I think in summary, the best one I can recommend at the moment is the Kepware server.
Great. Can VTScada be configured as an OPC-UA server?
No.
Short and simple. Can the system use communications via radio or wireless?
Yes, as long as you can get a TCP connection over those transport mediums. In essence, we really don't care as long as the TCP packets get to the other end and come back again. It may, I can't see any reason why it wouldn't work. We definitely haven't tested that, but we do run TCP over those, over wireless and radio for other protocols. So I don't see why it should be a problem for OPC-UA, but I cannot hand on heart say I've tested that.
Fair enough. Okay, I think that's all of the questions we have so far. If you're typing, I'll just vamp a little bit in case you need to hit enter. Nope. So on that note, if anything does come in, we'll just tack that on to the end of the video. So thank you, everyone. Thank you, Graham, for doing such a great job. And thanks to all of you for tuning in and staring at your screens and listening to people talk for a half an hour. That's always a difficult thing. So I thank you as well for your time. Tune in next time and have a great day.
Bye now.